Hello, friends and channel viewers. A hearty welcome to my YouTube channel and myself, Professor M.H. Annaya. Friends, in today's video, we are going to learn how to design a ball bearing to sustain a given load for a given period when the diameter of the shaft or the bearing is not known. And friends, if you go through one of my previous videos on the same chapter design of ball bearing, you will know how to design a ball bearing when the diameter of the bearing or that of the shaft is known to us. Friends, in today's video, we have the question reading like this. A single row ball bearing is to carry a load of 2 kilonewton, that is radial load 2 kilonewton, and axial load or thrust load of 3 kilonewton, and it has to sustain light shock, and it has to be in use for 3 years at 10 hours per day. The speed of the shaft is also given, and we have been asked to design the shaft or select a particular bearing, suitable bearing, that is SKF bearing, to sustain this load. Friends, in the design of ball bearing, generally the most important type of problems are to design a bearing when the shaft diameter is known, and to design a bearing or to select a bearing when diameter is not known. So in today's video, we are going to do the problem under the second category, that when the diameter of the bearing is not known. Friends, a common step common to both type 1 and type 2 problems, that is when diameter is known and diameter not known, we have the first step in the design as calculation of the life of the bearing in millions of revolution. So friends, in step number 1, we are going to find Ln, the life of the bearing in millions of revolution. As I told before, it's a common step in all the ball bearing design problems. So friends, Ln can be written like this. So it says it is to run for 3 years. So the bearing will be in use for 3 years at 10 hours per day, and the RPM of the shaft, the speed of the shaft, is given to be 1200 RPM. So this data I am going to convert it into revolutions and then to millions of revolutions. That is how the life of the bearing Ln is expressed. So I am going to convert this 3 years by multiplying by 365 days. It becomes so many days into 10 hours per day. It will give the time in hours. That hour I am going to convert it into minutes by multiplying by 60. It becomes so many revolutions per minute. So multiplied by RPM is 1200. Friends, if I am dividing this by 10 to the power of 6, we get the life of the bearing Ln in millions of revolution. We call it as MOR, millions of revolution, and this works out to 788.4 millions of revolution. That is, we have to have a bearing, a suitable bearing, which will make 788.4 millions of revolution before it is discarded or thrown out from service. That's the meaning of this Ln. Friends, after finding out the life of this bearing in millions of revolution, we'll move on to the second step. So in the second step, we have to have the selection of bearing. Step number 2 is Selection of bearing. Selection of bearing means what or which type of bearing or what size of bearing will be able to withstand this load, axial and radial load for a given period. Friends, for the ball bearing, we have the formula Ln is equal to C by P to the power of 3. This is the formula for ball bearings. Similarly, for the roller bearings, you have got this Ln equal to C by P to the power of 1 by 3. So here friends, to know the value of C from the data handbook, we should know the diameter. So here, we do not know the diameter of the shaft or the bearing, and hence we cannot find out the value of C. So here, to find out P, which is equal to XFR plus YFA, and that is multiplied by service factor. We should know what is X, what is Y. Service factor is known to us because the bearing sustains light shock or subjected to light shock. Friends, the concept behind this is very simple. See, in the type 1 problem, when the diameter was known, for example, say we have got these two columns. Simply I am showing two columns. This is the diameter of the shaft. This is C and this is C naught. If you refer to the data handbook, this information is given. So if you know the diameter, say some 60 millimeter dia, you will have corresponding to that the value of C, so many newtons, maybe 28,000 newton, and this may be 20,000 newton. Like this you have got a table. So if you know the diameter, you will be able to get the value of C and C naught, which can be substituted in the formula to obtain the diameter of the bearing. Now the procedure is in the reverse order. That is, somehow you should be able to calculate the value of C by using Ln equal to C by P to the power of 3 and know the value of C. That is, if you know diameter, you get C and C naught. If you know C, you will be able to get what is the value of the shaft diameter. So this concept you should remember very well. So let's see how to find out that. Friends, when the diameter is known, you are able to get C naught from the table and you are able to find out what is FA over C naught. So FA is given in the question, C naught is obtained from the tables based on the dia, you will be able to get it. And once you have this value, you will be able to find out what is E, the constant E. But here friends, since C naught is not known to us, we are going to assume a suitable value of FA over C naught. That is, assume there are about 8 to 10 values given in the data handbook. We can assume FA over C naught some value, say 0.056. This is available in the machine design data handbook. So corresponding to this, we have E is equal to 0.26. So we are making an assumption here. In the previous type of problem, we used to calculate FAO C naught based on C naught available. That was based on the shaft dia. Now, since diameter is not known, we are going to make an assumption and take some suitable value from the machine design data handbook and note down the value of E also. Now, for the given bearing, we have FA over FR. FA is axial load. It is 3 kilonewton and carry radial load of 2 kilonewton and axial load of 3 kilonewton. FR radial load 2 kilonewton. So friends, we are going to get 1.5 as the ratio. So after getting the ratio, we are going to compare this value of FA over FR with E. So I will write down comparing FA over FR equal to or with E, comma, we find FA over FR is equal to 1.5 greater than E, which is equal to how much? This value is 0.26. So therefore, whenever this ratio is greater than this E, we have x is equal to 0.56 from the table and y is equal to 1.71. So friends, these are the values of x and y based on this concept. When comparing FA over FR with E, we find the ratio greater and hence we get the value of x and y from the handbook. So friends, we go back to that formula. Ln is equal to C by P to the power of 3 or C cube is equal to P cube into Ln, or the value of C is equal to P into cube root of Ln. So this Ln we have calculated as 788.4 and this P value you will have to find out. So friends, P is equal to x FR plus y FA multiplied by the service factor. So x is 0.56. The value of radial load is radial load 2 kilonewton, 2000 Newton plus y is 1.71 into axial load is 2000 is the radial load, axial load of 3 kilonewton multiplied by service factor. See friends, the bearing is subjected to light shock. So we are going to multiply this by 1.25. And friends, this value of P works out to 6375. 6375 Newton. This is the value of P. So we are going to put this value of P here and obtain what is C. So this is 6375 multiplied by cube root of 788.4, and friends, this works out to 58592 58592.5 Newton. This is the dynamic capacity of this bearing, that is the value of C. And friends, what happens after getting this value of C? We can refer to the table and find out what is the nearest table value. When you go back to the table, that is the medium series he has given. Medium series means O3 series. In that O3 series table, if you refer to the table, there is a value which is nearer to this. It could be slightly higher or lower, does not matter. We have the value of C equal to 61850. I have taken a little higher value. This is the calculated value and this is the value we have got in the table, machine design data handbook table. So corresponding to this C, we have C naught is equal to 38,000 Newton. So the purpose of calculating this was to find out the actual value of FA over C naught. Friends, now we will obtain or we will check what is the actual value of FA over C naught. We have C naught with us. FA is already given in the question. Therefore, we will say FA over C naught is equal to FA, the axial load is 3000 Newton and CO is 38,000. And friends, this works out to a value FA over C naught is equal to 0.0526. 0.0526. And this is the value of FA over C naught actual. And nearest table value of FA over C naught is equal to 0.056, for which E is equal to 0.26. Friends, we got the value 0.0526. Nearest value is 0.053. This you are going to get by 3. This is 0.056. Now friends, the assumption whatever you have made, that is FA over C naught is equal to 0.056, which is very closer to the actual value of FA over C naught we have calculated. And hence, we can certainly select this particular bearing, and corresponding to this value of FA over C naught or corresponding to FA over C naught is equal to 0.056 and the value of C equal to 61850 Newton, comma, we select. What we do, we have that C column. From the C column, we have to move to the first column where the diameter is given. So we know the value 61850. Under this medium series ball bearing, you can select what is the size of the bearing. So corresponding to this, we select the bearing having diameter 50. We select 50 BC O3 bearing. And all what are the values you have used? All are taken from this C, C0, etc. Because it's asking us to medium series ball bearing. So this is O3 is medium series, O2 is light series, O4 is the heavy series. And we select this bearing. And friends, corresponding to this, we have this SKF designation as 6310 bearing. 6310 bearing. This is how this is designated. So we have selected the bearing, and at the end of this selection, you can write a simple sketch of that single row ball bearing and show the different parameters. So friends, I will simply write a simple sketch with a small period at the ends, and here we have the shaft dia, which we call it as small d, and that is equal to 50 mm. You have this single row ball bearing like this, the outer race and inner race. And friends, this is the width of the bearing B. Shaft dia, this is fillet radius R and R at the four ends, and this is the maximum diameter capital D. So corresponding to D equal to 50, this is 110 mm, that is the maximum diameter of the bearing or the diameter of the bearing. And we have this B equal to 27 mm. This B is 27 mm, and the fillet radius R, this R is equal to 2.7 millimeter. So we can have a simple sketch written like this. This is how the single row ball bearing will look. Friends, I hope the presentation was interesting. Please go through the complete video without fail. And if you like this video, please share this video with all your friends without fail. Wish you all best of luck. Have a wonderful day.